Okay, well, thank you, Kasha, for inviting me to give this 5-minute pitch. We are going to talk about screen printing technology and more specifically how to screen print sub-30 micron patterns. Our mission as a group, as a company, is to work together with everyone that you see in this graph, the mesh, the emulsion people, paste, substrate, printing machines, in order to help advance screen printing technology. I will focus mainly on the very center one, talk more about emulsion and mesh than anything else. So what is necessary to be able to achieve sub-25 micron or sub-30 micron features that everybody is so desiring to do these days? Well, the very first thing that we notice is we need a black stainless steel mesh, which is what you see here on the very left-hand side of the picture. Conventional stainless steel meshes look a lot more like this one on the right-hand side. And the reason why we decided to treat the mesh and give it this darker appearance is to minimize random reflections during the emulsion exposure to UV light. Here on the right-hand side graph, you can see specifically in the area where they're very sensitive to these parts of the spectrum, 405 and 360 nanometers. We see that with black mesh, you don't have the random reflections that occur on a conventional mesh. Second, we need superfine resolution emulsions. What I mean by that is high resolution photosensitive emulsions allow you to develop narrow openings and to obtain sharper edges, as you see here with these 30 micron features and 20 micron features. And third, and this is the area where I'm going to spend a lot of my time, is we recommend at this point to use meshes with 11, 13 micron wire diameters. And these meshes, generally speaking, have an open area around 55% to 65%. These are some of the sample products that we currently are working with. We have done a lot of work this past year, 2021, with 511 and 43013. I'm sorry, 513 and 43013. So we truly recommend these meshes to be used if your targets are 25 and 30. So how do we figure out the percentage of open area and the theoretical wet print? It's a very simple formula. I have done it for both of the cases here. You multiply the mesh thickness times the percentage of open area and you obtain the theoretical wet print. So in the case of 43013, as you can see here, it has a 60% open area, 60.8, and in the case of 513 is 55.4%. If you take the formula, you multiply the thickness of the mesh times the percentage, your theoretical wet print. The theoretical wet print then could be multiplied by the percentage of solids that you have in your paste, and you will obtain your dry thickness deposit. One other thing that you saw at the very beginning is the substrate technology circle. Super important. Last year we worked entire year in testing different substrates. We knew that we needed to match the surface tension and the surface condition to the different pastes that exist out there. And obviously in a 50 micron pattern, I just decided to put out some samples. You can see the poor results with jagging or post stamping. Here there's a little bit less, and this is optimal condition. So what's the key? The key is proper screen, proper substrate paste, and squeegee selection. This is the work that we performed last year, where we now are at 22 micron lines. And I thank you for your attention. We have a booth if you wish to talk to me today. I'll be there. Thank you, Kasha.